This is our final lesson for redox reactions, and it's going to get you prepared for the assessment that you'll be doing, so you'll know exactly what's coming up. And there's 2 practice assessments in your workbook. So in the assessment you will be given a table, which is on the next page, of all the species you're going to need in the assessment. So you will know how to write those ions because they'll be written there, and you'll know what colours they are. And so you'll just have to pick out of that table what species you started with and which you finished with. And having done that, you will then write the half equation for both the reduction and the oxidation reactions. Then you'll add the 2 equations together to make a whole equation, as you've practiced already. And finally, in the final whole reaction, you will circle the oxidant and you will put a rectangle around the reductant. For excellence, you'll justify your choice of choosing that oxidant and that reductant in terms of has it lost or gained electrons. Okay, so what we mean by that is you would say something like this is the oxidant because it was reduced. Remember, anti, when it's got that ant in it, that means that if it's the oxidant, it's anti that, it's been reduced. And when you know it's reduced, you're thinking of Rig. Reduced is gain, so you're saying it's gained electrons. And the opposite is so for the reductant. It's oxidized and it's lost electrons. So if you want to, you could think of a red ant here. Red ant. Picture a red ant for reductant. And the red ant is sitting on a puddle of oil. So that's going to remind you, and all of that's in a rectangle. So if you've got this red ant and it's sitting on a puddle of oil, you're going to remember that when you say something's a reductant, then it's all about oxidation is loss. Oxidation is loss. Or if you are choosing an ox ant, don't really want to have to draw an ox, but say you've got an ox and it's got a little ant on it. So the ox ant is somehow in your mind on a rig, because reduction is gain. So we're talking about ox ant. We're going to put a circle around it. It's the ox ant's on a rig because reduction is gain of electrons. So if you can just tie those terms together in your mind, that's going to help you get excellence in this assessment. So you will be provided with this table, as I said, and a story about what stuff that they've thrown into a test tube. And so basically, say if you know that you've got copper metal in the test tube, you'll want the copper atom, which is this one, and you'll look down this list and think, okay, what could it have possibly turned into? It can't change from copper into any other element, and the only other copper here is the Cu2+. So your half equation must be Cu2. Okay, so it's easy for most things. In the story, if they're saying chloride, then whenever you've got ide, you've got a minus sign. So bromide must be a minus sign. Chloride and iodide. Think of when you died. When you died, it's a negative thing. So died, if it ends in died, it's negative. Okay, so for iodine, this is not negative, but for iodide, it is negative. Okay, so iodine is I2, iodide is I minus, so they would go together. Hydrogen sulfite, it's got sulfur in it, and the only other thing in here that's got sulfur is sulfate, so that must be the half equation. The tricky one I've mentioned here is hydrogen peroxide. This thing here, it could go to water when it's reduced, or it could go to oxygen when it's oxidized. And in this case, one of your clues would be that oxygen is a gas, so in the story the product would be bubbling, a bubbling colourless gas, or bubbles appeared. Okay, so whenever you see gas, you know that you should be seeing or noticing bubbles in the reaction. Okay, so this is what the assessment's going to look like. You'll be told if something's added to something. So we've got hydrochloric acid is added to zinc metal. Oops, zinc metal. So we've started with hydrochloric acid and zinc. Now, whenever we've got an acid, the thing that's doing the reacting is the hydrogen ion from that acid. So we're not actually interested in the chloride here. It's the hydrogen ions. So all acids, it's taking part in a reaction. For the redox, we're just worried about the H+. Okay, so we're going to look at the table and go, what could H+ possibly go to? And you'll actually do the reaction and you'll see bubbles form. So you're wanting a gas, and H+ would go to a hydrogen gas. So what you would see, what you'd be saying here would be bubbles form. And you'd be seeing that the zinc metal, so the silver zinc metal, corrodes, gets smaller or disappears completely. So with the zinc, you would have started with zinc atom and gone to zinc ions, because you see in the table that zinc ions are colourless and they're aqueous, which means that they are dissolved in the water. So the zinc is a solid and the hydrogen is a gas. Okay, and in the acid, the hydrogen ions are dissolved in the water. Okay, so for this column here, you're saying what you see, that's your observations. In the middle column, refer to the redox species and explain the bubbles. So here you would go, well, the H+ is colourless, and in solution, and H2 is a gas. So that's explaining those bubbles. Here you would be saying Zn is grey solid, and you get this information off that table from the previous page, and zinc 2+ is colourless. Okay, I'm just going to say colourless is cull from here on. Okay, so that's what we're writing in those boxes. Then with this half equation, we're going to do our balancing the half equation thing. So we're adding electrons to the most positive side. Firstly, I've got to make sure that there's the same amount of each thing on both sides. So I've got 2 hydrogens here, 2 hydrogens here and 1 hydrogen here. So first off I may need to make that 2 H pluses. Now I've got to worry about the charge. So here I've got 2 plus charge and here I've got 0. So remember we add electrons to the most positive side, which is the left, and I've got to make it equal the right side, which is 0, so I have to add 2 electrons. For the zinc one, it's pretty straightforward. There's only 1 zinc here and there's only 1 zinc here. With the charge, there's 0 charge for the atom and there's 2 plus charge for the ion. So the most positive charge is on the right and it's 2 plus, so I need 2 electrons. Okay, so now my half equations are done. And to write the whole equation, remember I've got to look and see, is there, firstly to check if I've got electrons on the left for one of them and I need electrons on the right for this other one, otherwise I've done something wrong. Every redox reaction has to have an oxidation equation where electrons are lost, so that would be this one, oxidation is loss and reduction is gained. So I've had electrons added here, so this is the reduction. Okay, so I look at it and I see, okay, there's 2 electrons on the left and there's 2 electrons on the right, so I don't need to multiply any of them. They can be added directly together to make the full balanced equation. So I'm going to go 2H plus zinc. Okay, so I'm just writing everything that's on the left of the arrow for both of the half equations. Goes to H2 and Zn2 plus. Okay, the electrons, remember, cancelled each other out, so I don't have to write about them. Then I'm going to work out which is the one I'm going to put the rectangle around. Okay, so remember the 3 R's. 3 R's say that if it's on the right, electrons are on the right, which is what's happened here with the zinc one. So I want the zinc to be in my rectangle because the electrons are on the right, and I want the other one to be the circle because the electrons are on the left. And then explain in terms of electron transfer, and this is when you want to use the red ant oil thing. So red ant is the one in the rectangle, so I'm going to go zinc is reductant as it's oxidized, remember oil, and lost electrons. Oxidation is loss. And then we're going to go, the H plus is oxidant as it's reduced and gained electrons. Okay, and that's all you have to do for each question. Then finally, the last 2 equations that you're given will have something in common. So in this example you had iodide in one of the reactions and iodine in the other one, and so for the excellence you're going to be comparing and contrasting those 2 reactions in terms of electron transfer. So you're simply doing what you've done before, but just in a comparative sort of way. So in the first reaction, iodide is the reductant because it loses 1 electron and is oxidized. In the second reaction, iodine is the oxidant because it gains 1 electron and is reduced. And you also have to write about the other participant in the reaction as well. And having done that, you can get an excellence.